Thank you. So no questions, it's not the case. You can ask me questions afterwards and we can discuss afterwards, as said in the presentation at the beginning. Yeah, welcome. Thank you for showing up to my talk, first talk of the day. Exciting. First of all, I'm not doing a lot of Ruby at the moment in my job, but I think what I'm going to talk about is applicable to a lot of languages. And I try to adjust some of the slides to match Ruby. I set up a Redmine to do that. So I think it should work. If you have any questions regarding how it could work with Ruby, talk to me afterwards and we can see what I can tell you. The other thing, I would like to know how your experience is with the topic I'm talking about, so I would like you to raise your hand. First, who has worked with Docker before? And Docker Compose? Same amount, okay, that looks good. So I can keep the part short, I think, where I talk about Docker. Thank you. What is this about? In general, we are getting more services, more languages, more diversity in our stacks. There are a lot of different versions of software and also a lot of teams working on the same software, especially if you have a big company, but also small companies tend to split their system up and distribute it. But it's hard to, in a setup like this, it's hard to run the whole system on your machine locally. The problem with this is you don't really have a way to build confidence in what you are building. So especially if you're a full stack developer, as I am, I build stuff in the front end, I build infrastructure, I build the back end part, and when I have built it, I want to see it running. Of course, there are tests that should be running, there's code reviews, there's a lot of things that you should be doing to build your confidence in your code and what you have built, but there's nothing like seeing it really run in the way it should be. And with all those diverse services, it's really hard sometimes to set up the whole system on your local development machine to run, so you can test everything. So the idea and what I've experienced is using Docker to build a Devbox. So Docker and Docker Compose allow you to configure your services to run on your local machine and in containers. The containers have a small operating system, kinda. It's not really the whole operating system. The kernel is reused from the system below, but in general you have your Debian or Alpine or whatever, and then on top you can install all the packages, all the dependencies of your application, and then you can run your application inside this container. And Docker Compose allows you to compose those different containers and tell them how they should be started, what's the environment. You can link files into the container and compose them and even link them together so they can talk between each other. And those services can be the service you build yourself, but also the database or a cache or whatever you can think of. Everything that you need, also need to run your system in production. So the requirements for such a Devbox would be that it should act like a local staging environment. It should be usable during development, so I want changes that I do in my editor to be reflected in this running system as fast as possible. And it should be easy to bootstrap and use because you don't want to fiddle with the containers all the time. It should be something that you just can plug and play. My experience with a system like that is coming from from working at Jimdo. At Jimdo we have an old product we call the Creator, and with the Creator we are using a setup with Docker and Docker Compose to run our whole system locally for quite some time now, I think several years. And we have had quite good experience with this. We even use it during our pull requests, to run integration tests. So we spin up a whole system during the pull request run our Cucumber tests against it, and then it automatically is shut down again. And we now have a new product called Dolphin, and for Dolphin we are at the moment in the process of setting up a Devbox as well, and the feeling of getting more confidence in deploying the changes is also coming back. We had a system where we had a staging environment which was slow because you have to deploy to the staging and then you have to wait for it and test it there, and if it doesn't work you go back, do the change, deploy again, and with Devbox you have this immediate feedback which feels a lot better. I said that we want the Devbox to be like a local staging system and as close to production as possible. And to do that, one thing that we probably want to have is a domain, because you don't really run your services online by exposing ports and giving people ports and telling them, please go to this port and go to that port, but you have domain names. So first thing to do is get a domain. This can be done quite easily. You can use the TLD test. This is reserved and is exactly for this use case to run something on your local machine or local network. So you can choose a domain with the TLD test. And if you want to use this domain, you need a name server that responds to requests for this domain. Luckily, you can just start a DNS server in your Docker environment and tell your machine to ask this name server for the domain. So you have, for this example, choose devbox.test, and with this etc resolver devbox test file, you tell your OS X. I don't know how this works with Linux, but there should be a way as well. You tell your resolver for OS X, please, if there is a DNS request for devbox.test domains, ask this name server. And then I have this fixed IP. You can just set this up by creating a local loopback device with this IP. And bind your web server to this IP address. I just saw I messed this up, so it still works, because if you just define the ports, it binds to all, to 0000, but you can also just specify where in the port section to just bind to this specific IP address, and it would just be bound to that. And if you run the DNS mask on this this port with the configuration devbox.test, it will always return the same IP address, and this IP address is the IP address you use for your containers. So first part is done. I can have a DNS, and if I go to my browser and type in devbox.test, it will point to the container environment. Now, we don't have anything running there, so we will get no response, but this can also be easily solved. There is a nice project by Jay Wilder. It's called Nginx proxy, and it's a proxy that's, that comes with a lot of features, but the main feature is that you can just plug it into your Docker Compose file, and it will use some other code that is also written by Jay Wilder and available separately that will parse the configuration of different services and take this configuration and pass it into other containers. And in this case, it will go through the environment configurations of all the services and look for virtual host and virtual port environment variables and use those to see under which subdomain a service should be hosted. So you bind this proxy to the HTTP and HTTPS ports and just tell it virtual host myservice.devbox.test. And if you launch this service, then you will be getting a service running under this domain. So now we are able to just add services to our Docker Compose file, and they will be available under subdomain names. Yes. The next thing that you probably want to have, because in production this is a default, hopefully in most cases, is encryption. And to do that, there are tools like, for example, rcrowley's certified tool, but there are also a lot of others, and you also can just use OpenSSL to generate your own CA, and then self-sign a certificate for the wildcard domain star.devbox.test. And if you have this certificate, you can then go ahead again with the JWilders Nginx proxy and configure it to use this certificate with the mount you see up there where it says certs and the cert name configuration on your service, and tell it, please, for this service, deliver HTTPS and use this certificate. Now, this unfortunately, this doesn't work right out of the box because your browser or your operating system won't trust this certificate. So you will have to go and import the public key of the CA into your browser or operating system. One thing that you have to be careful about is if the private key of the CA gets leaked somewhere, the person who has it can generate certificates that your operating system or browser will trust. So keep it safe, or you could even just throw away the CA certificate private key after you have generated your wildcard certificates key. And if you need a new one after it expires, you can just generate a new CA and import it again into your operating system and browser. So now what do we have? We have a Docker setup where we have DNS that responds to our domain. We have the proxy that proxies all the requests to HTTP and HTTPS through to our services, and we also have certificates so that we can use it as we would be using it in production. Next thing would be to run all your services inside the Docker Compose or inside the Docker environment. And this is the messy part, depending on how your current setup is. So at Jimdo, we have the luxury of already running all our services on Docker in production. So for every service, there has to be a Docker image as an artifact. And when setting up this Devbox, we could just use those. In theory, because even with existing Docker images, you can have problems like baked-in configuration files. So they can be already imported. The configuration could be imported in the image, and you have the prod image and the staging image or whatever. Or you have even baked it. We had this case with Webpack where you have the different configurations in your Webpack configuration, and depending on how the environment variable is set, it would then either choose the one or the other, but there was no way to use our new environment. We would have to bake this into the Webpack configuration as well. or into the Webpack build to get the configuration available for this new setup. So this is quite some work, and it can get messy. I won't go into detail here what the different strategies are, because there are so many, and because it really is depending on how your current setup is. But if you have any questions about how a specific service could be imported, or what strategies there are, please come to me afterwards and we can talk about it. Yeah, so assuming you successfully took all your services that you need to run the system, maybe it sounds a bit frightening, but if you start doing this, it isn't really bad. It's especially for things like databases and caches and infrastructure, there are already images available, and even if you don't have a Ruby image for your Ruby service, there are images that are a base image for Ruby, and generally for most projects it works quite good to just take the code you already have and plug it into one of those existing containers and then or images, and boot them up and maybe do some additional configuration. But yeah, you shouldn't fear this step. It's quite nice, and it feels really good when you have the service running in Docker, because then there is no more configuring your local system to make it running over and over again and going to your Kia and setting it up there as well. But you just have to take the Docker file and give it to him, and he can spin up the same service with the same configuration, and the whole works on my machine really goes away. Yes, so we have the system running with all the services we need. What else is there? There is data, especially if you develop, you have pictures that you want to have in the system, you want your database migrations to be run. There is also things like additional gems you want to install, or whatever. For this kind of thing, a very good approach is to just call the same functions you would be calling on your local machine through Docker Compose Run. Docker Compose Run will take the same configuration that you use for your service to run your service, and will start a machine or a container up and execute this same command inside of the container. And I've had good experience with just doing, just executing the commands inside the container. Sometimes you have to do some additional configuration, but with some fiddling, this works quite well. Then this looks strange. This wasn't supposed to look like that. But if you want to have communication between your services while using SSL, which sometimes is needed, sometimes your services are configured to always use SSL for communication, which is good practice, I think. You will run into the problem that you need to provide your development certificate, CA certificate, to your services. This is not a big problem, but something that you need to know. You can import the certificate into the CA of the operating system just by either putting the certificate in the certificate store and then updating the certificates, and it will generate a file, or you pre-generate this file and put it into the place where your operating system expects the file of all the certificates you want to use. Unfortunately, this doesn't work out of the box for all languages. I don't know how it is for Ruby, but for Python, for example, we had this last week, there is there are services baked into the different libraries. So I think OpenSSL is bringing its own library of certificates, and then there is the request library that also brings its own certificates. But there are often configuration variables that allow you to tell those libraries to use the system certificates, and then it's easy to just replace the system certificate store and tell your application to please use the operating system's certificate store. And then the services can talk between each other through SSL as well. So now everything is running, the services can talk to each other even through SSL, but we still can't develop using this thing. If we want to develop, we want to do something like mounting our source code into the system. This works well with scripting languages. For compiled languages, so Ruby should work fine. And I also have experience with PHP and Python and JavaScript working well. I haven't experience with things like Go or Java, where you really compile an artifact and then run this. I think it should work as well, because at least for Go, I know there are tools that will detect file changes and automatically recompile your code and host the server again. So something like this probably would work as well. So what you can do is just mount your, the indentation is not right here, but so you mount your source code into the Docker container, and you might also want to do something like bind your bundle directory to a specific path, so you don't have to reinstall the bundles every time you restart the service. And ideally, you are good to go then. Sometimes you might have to change configurations, do things like have different environment variables, set the system to development mode, but you can do all of those things by just configuring them in your Docker Compose file and using a nice feature of Docker Compose that is inheritance. So you can have two Docker Compose files and list those two as configuration for your Docker Compose setup. And in the first one, you just have the whole setup for your Docker Compose for all the services running normally without being development services. And then you have, for a specific container that you want to develop, you have an additional development configuration that you just add to the arguments of Docker Compose. And when you start it up, it will start up in development mode for this particular service, and then you can start developing. One important thing, for most of the services, especially those that need to restart the server or recompile or whatever, it is important that you have that the file system events get forwarded to the container. This doesn't work with Docker machine, so because the NFS mount doesn't forward those into the virtual box you are using, and then it doesn't get forwarded to the container. In my experience, Docker for Mac does this very well, and it should also be working fine if you are working under Linux and have your daemon running directly on Linux and not in a virtual machine. Yes. What else? Since we are at Docker Compose features, there are also nice features you can use to spice up your configuration. For example, there are placeholders you can define and then insert. So, for example, for the DNS, I defined the DNS server configuration, and then I can just insert it with those arrows. You can include environment variables. So you can, for example, use an .env file and have your secret stored in this .env file, and it will automatically get sourced by Docker Compose and used. Okay. And you can also, I don't know why I put reuse here, but yeah, you can do that. One thing that's missing for me is defining includes. That would really help, because you could then define all your services in different configuration files and just have one file that you include all the services into, because it becomes quite messy if you have this one big Docker Compose file with all your services in. You can do something like I have down here with the Compose file, where you define all the Compose files that should be loaded in an environment variable. But you probably would have to generate this dynamically, automatically from those, from a folder of Docker Compose files or something to really use this in an easy way. Then one thing that is good to know about, especially at the moment where there was an update, how the project name is handled for Docker Compose. Previously, it stripped so the Docker Compose project name is automatically generated from the folder you run it in, and previously it stripped dashes from the name. This doesn't happen anymore with new versions, so you get two different variants of the project name. If you want to be sure what the project name is, you can just define it in an environment variable, and I would recommend to do that. Some caveats. This is not for me, or it doesn't show up there, right? So, some caveats. Works on my machine. I said it doesn't apply anymore, but it kind of does if you look at the operating system, the network setup, Docker version, and Docker Compose version. You have to make sure that this is somehow aligned between your setups, or provide different tooling for them. In terms of tooling, I would recommend to have some tooling to set up the environment, so execute the, place the DNS file at the right location and restart your DNS server to enable it, and maybe have some convenient scripts for booting up the machine and doing the migrations. Also, this can easily break if not everyone is using it, and also probably, I don't know how this is, but if you don't use the Docker containers to deploy to production, I could imagine that having the Docker part working is not really a priority for people if it isn't the main artifact that gets deployed as well. Yeah, so that's it for me. Here are some links for the libraries I used and images I used. And here's some info on me. If you are interested in anything like Docker or Ethereum smart contracts or Raspberry Pi running serverless, talk to me. Also, if you have questions, feel free to talk to me and we can see if I can answer them. Yeah, thank you very much. One thing I like to do when I do retrospectives is a fist of 5, so I would like you to raise your hand into a fist and tell me how good the time investment was from your side being in this talk. So a fist is very bad time investment, and 5 fingers is the best time investment I could imagine. On 3, please, if you would. 1, 2, 3.
Seeing a lot of fingers.
All right, thank you. Nice day.